The first step of a lot of equilibrium problems is writing the equilibrium expression. The equilibrium expression is just the ratio of products to reactants accounting for your coefficients. So in example A, we've got ammonia and oxygen making nitrogen dioxide and water. We'll put our two products on the top. They are raised to their coefficients as exponents. Our two reactants on bottom, coefficients as exponents. An important piece here is to pay attention to the states of matter, which we'll see in the next one. We only include gases and aqueous components, and we also want to pay attention to if it's asking for a Kc or a Kp. With Kc, it is looking for concentrations, so we would be using the square brackets, which imply we're talking about molarity. For Kp, we'd be looking for pressures in atmospheres, so we're going to use the letter P to show that we're looking at the pressures. In the second example, we've got CO2 with H2O liquid, a little bit different, making hydrogen ion and the bicarbonate ion. So if we're looking at Kc, it's still products of reactants. We can include anything that is aqueous, anything that is a gas. This one would be a little bit tricky in terms of a calculation, and you wouldn't be asked about that on the AP exam. But both aqueous and gaseous components do have concentrations, like how much of the total solution or the total volume is occupied by moles of that thing. So we can have molarity of each of those. And then the bottom one, I have a Kp expression. The difference with Kp is that we're looking at pressures, and the only state of matter that exerts pressure is the gaseous state. So our products, we have no gases. Our reactants, we only have one gas. We don't have any coefficients in this one, so we end up with no exponents. So just paying attention to your coefficients, paying attention to states of matter, and paying attention to whether it's Kc or Kp.